Hello, my name is Professor Johnson, and today I will go through a tree diagram example. So suppose there are 20 red marbles and 13 blue marbles. They're mixed together in a jar. First, draw one marble from the jar and record its color, and then without replacing the first marble, we'll draw another marble and record its color. Represent this situation with a tree diagram. Okay, so with a tree diagram, we can draw kind of these branches. So I'm going to make two branches here. One of the branches I will mark as red, and the other marking would be a blue. Okay, and that's because we have a blue path. So we have 13 blue marbles in one path and 20 red marbles in the other path. So we have this red path and then a blue path down these branches. Okay, now this first branching, this is all about the first draw. Okay, so this first branch that we've made is all about the first draw. And what I'm going to do is put the probabilities of drawing that first marble along the branch. Okay, which is why it's called a tree. They're like tree branches. Okay, right here, this kind of is like our starting point, and you're either going to pick a blue marble or you're going to pick a red marble, right? Now, what if we had like red, blue, and then orange? Well, then there would be another branch. What if we had like red, blue, orange, and then white marbles? Well, then we would build another branch, and we would just have more probabilities. So in this example, we'll just have two. We'll try to keep it simple. Okay, now what we need to know is how many total are there? Well, to get the total, you add 20 and 13, because there's 20 red and 13 blue. So we can see that there's 33 marbles total. So our probability would be something out of 33 for each of these. Now what I know is that there are 20 red marbles, right? If you consider this red path, there's 20 red marbles out of 33 total. So that would be the probability of selecting one. And then if you go down the blue path, that would be 13 out of 33. Because that is selecting a blue marble. So we've created our first paths, okay? Now I'm going to do this again. So if we've gone down the red path, right? If we've gone down this red path, now we are going to split off, right? The first drawing, now we will have a second drawing. So we're going to consider the second draw. We're going to draw more tree branches. So let me do that. I'll mark it like so. So we have more tree branches now. Okay, I'll give myself a little bit more room. Now, still in the total jar, there's red in either of these examples. There's also blue marbles in these examples. Okay. So now that we've drawn one marble out though, right, we had 33 marbles in the first drawing. Now that we've drawn a red one, suppose you're on this path right now, suppose you're on the red path, you've drawn one red one. Well, how many marbles are left over? Now there's only 32 marbles, because without replacement means you've kept the marble with you. And no matter what, whether you went down that red path or down this blue path, right, if you pick the blue marble, well, it's still total, there's only 32 marbles now. That's key here because we have without replacement, right? So we kept the first marble, or we kept the first marble drawn. Okay, we had 33, now we only have 32 marbles left. Okay, so now let's also consider what the probabilities of each of these would be now. Now there's 4 different probabilities we have to figure out. So going down the red path, if I go down this path, I've picked a red marble. How many red marbles are there left to pick? Well, we had 20, less 1 would be 19 marbles. And then if we're still down this path, but now let's branch to the blue marbles, Well, if you picked a red marble in the first drawing, you never even touched the blue marbles, right? So in the jar, there's still 13 marbles total in the jar. You didn't even touch the blues. You only grabbed one red one, plucked it out, and kept it to yourself. So that would complete that pathway. Now let's go down the blue pathway. So we pick a blue marble. We've kept it. We don't replace it. How many blue marbles are left in the jar now? Well, we had 13. We kept one. So now there's only 12 blue. And if we pick another blue, right, that probability would be 12 out of 32. Okay, so let's suppose we pick a blue. So then there's less one. There's 32 marbles overall. But we did not touch the red marbles, right? So there's still 20 red marbles in the jar to be selected from. So 20 out of 32 would be its probability of being selected, a red one. Okay, so we have completed our entire diagram. Now let's look at some probabilities. So let's find the probability of drawing 2 red marbles. Okay, 2 red marbles. So in order for that to happen, the first draw and the second draw would both have to be drawing red. So I'll highlight this with green. So getting 2 red marbles, well, this is how the tree branches help us. So we start here at the beginning, and then we move down. First draw, we get a red, and then we go down, second draw, we get a red. So we're following that pathway. We will multiply the 20 out of 33 times the 19 out of 32. So we just multiply through the path. So 20 out of 33 times 19 out of 32, and we will simplify that fraction. So I'll take my calculator, I'll turn it on. I can put parentheses, 20 out of 33, multiply that by 19 out of 32, hit enter. Now, so we get about 0.3598. Now I like the exact answer, so what I will do is hit the math button, select number 1, hit enter, and I have 95 out of 264. So 95 out of 264. This will be the probability of drawing 2 red marbles. So like drawing one, then drawing another, right in a row. Okay, so that would be going down that 2 red marble path. But we know that that's not the only path you can take. So let's also look at the probability of drawing 2 blue marbles. So drawing 2 blue marbles, we could go down the blue path, right? Down the tree branches. So we start here at the beginning, right? Now I'm gonna go down the blue path, right? Draw 1 blue marble, and then I keep it, and then I draw again, it'll be down that blue path. So I have 13 out of 33 multiplied by 12 out of 32. So 13 out of 33 multiplied by 12 out of 32. And then when we multiply, we can use our handy dandy calculator and multiply. Hit enter, so we get about 0.15, but I like to have an exact answer. So I will hit math, enter on fraction, and then enter again, gives you 13 out of 88. So 13 out of 88 would be my probability. We always know probability will be values somewhere between 0 and 1. Okay, so we've considered picking red then a red, and a blue and a blue. Now, we also know that we could pick different combinations, right? We picked red then red, and we've picked blue and blue. But we also know that you could pick a red then a blue, or you could first pick a blue then a red, right? So either order. So that'll be the next probability I look at. Find the probability of drawing a red marble and a blue marble in either order. So I will have red then blue, or we can have blue then red. But in order to consider each of those probabilities, we must add them together. So we're going to have some multiplication going on, like we did down the branches before, but then we have to add the pathway, because either order could come into play. So let's see, red then blue. So if let's pick a different color. We'll go red, then blue. So you see you're down this path. 20 out of 33 times 13 out of 32. So 20 out of 33, 13 out of 32. Now we need to go the other path. So we will go the blue path and then down the red branch. So we'll pick blue, so 13 out of 33, 20 out of 32. 13 out of 33, 20 out of 32. So we can take our calculator and we will multiply 20 out of 33 multiplied by 13 out of 32 and add it to 13 out of 33 multiply by 20 out of 32. Hit enter, it's about 0.49, but we like the exact answer, so math, fraction, enter. We get 65 out of 132. Now we have considered all the different paths that could occur on this diagram. Now the diagram looks a little messy because of all the highlighting I did, but a good check with this to see if I've considered all the possibilities is let's just add these three values. So I can add the 65 out of 132, add that to 13 out of 88, and then add to 95 out of 264. When I hit enter, it adds up to 1. And it adds up to 1 when you add them all together, right? Because you have considered all the different possibility pathways that are possible. Okay, thank you for watching my video.